Hi, welcome to my easy algebra video on solving equations with variables on both sides. You've probably already solved equations like the one on the left several times in your algebra class. But have you seen an equation like the one on the right before? Take a moment just to look at the two equations and think to yourself, what's different and what's the same? Looking ahead to solving equations like the one we see on the right, how do you think that process for solving might be the same or different? They're probably more similar than you might expect. So now it's time to actually begin the solving process for an equation that has variables on both sides of the equal sign. But to start this out, we're actually going to use a lot of the same steps that we use for any other equation. Looking at this equation, I can see that I have a distributive property. So that's going to be the first thing that I do to solve this equation, is I'm going to distribute that 3 to both terms inside of the parentheses. Now my new equation is 2x minus 4 minus x equals 6x plus 6. If you only had the left side of this equation, what would you do next? Hopefully your next step would be to combine like terms. Since we have both a 2x and a negative x on the same side of the equal sign, we can combine those. My last step, that is similar for every other equation, is to clear any fractions or decimals you have in the equation. In this case, we don't have any. All of our values are whole numbers so far, so we can skip that step for now. So now, we're going to start moving into what makes this equation unique. Here at the top, I've taken our simplified equation from the last slide and just rewritten it. So now we have x minus 4 equals 6x plus 6. Our next goal is we need to get all of the x's on the same side of the equal sign. And this is actually very similar to how we move our constants. If we have, for example, a positive x, we can subtract that from both sides. Or we have a positive 6x on the other side, we could subtract the 6x. It really doesn't matter which one you choose. I usually like to move the smaller value though. By subtracting the smaller value, the 1x, it means that I end up with a positive x value at the end, and I just like to use positive numbers anywhere I can. Now we've got a basic two-step equation. We can finish this out from here using our inverse operations. By finishing out the problem, we end up with an x value of -2. Of course, as any algebra teacher will tell you, you can't forget the last step, which is to check your solution. You'll notice I have the original problem back at the top of the screen because we always want to use the original equation, just in case we made a mistake early on in our solving process. So we had x equals -2. Let's substitute it in and see if it works. So by following my check step, I've substituted the -2 everywhere that I had an x. And at the end, I got the equation -6 equals -6. Because that is in fact a true value, that means that, yay, we got this equation correct. So now here are two equations that have variables on both sides of the equal sign. Go ahead and pause the video and try these two equations out on your own. When you have the answers, hit play and you'll be able to check against my work. On screen are the solutions to the two equations. How did you do? If you didn't do well, check my work and see if you can figure out what mistake you made. Now we're going to move on and we're going to check out some special cases. I love stuff like this. In algebra, you will have something that works 90% of the time, but then the other 10% you have what I call weird math. And that's totally what we're about to see with these types of equations. So on the left, I have another equation that looks just like the ones we've been doing. We've got variables on both sides. But I want you to go ahead and start solving the equation and see what happens. So pause the video, and when you've run into something that's kind of kooky, I want you to restart and check out my math. So there were so many points during this that you may have run into something kooky. To start with, from the very beginning, when we distributed our 3 into the parentheses, we ended up with the exact same expressions on both sides of the equal sign. 15y plus 6 equals 15y plus 6. And if you tried to take it a step further and actually cancel out your variables, if you were to try to subtract the 15y, for example, from the left side, your variables completely go away and just leave you with 6 equals 6. And let's say you decided, well, hey, I'm going to follow this through to the end because I'm a finisher, and you subtracted 6 from both sides, you end up with 0 equals 0. It doesn't tell us anything about what the value of y is. And that's because this is one of our special cases that we run into from time to time. So take a moment and look. What happened to our variables? They all canceled out. And then what did you have left? We were left with only a true statement. 6 equals 6, or if you go down further, 0 equals 0. So then what is the solution to this equation? Because we didn't end up with a nice happy y equals a number, we're going to try to test something out. I want you to choose any value for y and plug it into the equation and see what happens. The really cool thing about this type of equation is that it doesn't matter what value you chose for y, you should have ended up with an answer that was correct. I chose 3. When I substituted 3 into y, I got a true statement at the end, which means that y equals 3 is an answer. And no matter what number you picked, the same thing would happen. When this situation happens, we don't have just one solution. We have infinitely many solutions because literally any real number will work. So if you see an equation like this, where your variables entirely cancel out and all you're left with is a true statement, the answer is all real numbers. But wait, there's more. I have another equation for you. Again, same thing as the last slide. I want you to try to solve this and then stop when you get to something kooky happening. So if you follow the solving process, you distribute, you combine like terms, you may run into something that you think looks pretty kooky early on. You end up with negative 12p on both sides, which, thinking back to that last problem, is not good because then they both cancel out. But if I continue this problem a little bit further on and I add 12p to both sides, I end up left over with 5 equals 4. And that is not true. Since this equation left us with nothing but a false statement, that means that there is literally no value that we can put in for p and have this equation be equal on both sides. It just doesn't work. There's literally no solution. So when you come across these problems where all your variables cancel out, you really have to follow through to find out, does it leave you with a true statement or a false statement? True statements mean that you have all real numbers, and false statements mean that there is no possible solution to this equation. So now, just to give you some practice on your own, I have 4 new equations available for you. Try them out. Pause the video, work the 4, and when you think you have the right answers, go ahead and hit play again to check against my work. So go ahead and check your work. How did you do? Did you pick out the no solutions versus all real numbers correctly? One other thing I want to point out. For all real numbers, I actually wrote the expression out here, but there is another way you may see it written. It's sometimes used as an R that has 2 vertical lines. Anytime you see that symbol, that means all real numbers. Thank you so much for watching this video. If you want to follow along with me, I do have the guided notes for this video available in my Teachers Pay Teachers store, along with several different activities over variables on both sides. feel free to check out the link below. Also, if you have any questions about today's video, please leave me a comment. I'll do my best to answer them and help clarify anything that you might not have understood when we watched it the first time. Also, if you have any ideas for things that you might need help with in algebra, let me know that too, and I will make an easy algebra video for that topic. Take care and happy learning.